Hey everybody, we're back with a special report from our ITC folks, and we have with us today Tim Greenen, who is the Director of Operations Engineering for ITC. I can get that right. And so, what we want to talk to him about is our energy needs are evolving, and we're depending more and more on electricity to power our homes and communities. Just think of all those smartphones and other electrical devices we use, not to mention cars, right? To keep power flowing no matter the conditions, proactive planning and redundancy in the electric grid is essential. And to help us understand what goes on behind the scenes to operate the electrical transmission lines, we have Tim. So let's start off with we always assume there's people in the audience because you guys are kind of the quiet big company, right? People are familiar with DTE and consumers because they're the last mile folks. That's not what you guys are about. Why don't you tell us what ITC does?
Sure. Well, the power that keeps the lights on in homes and businesses flows through a three-part system. So it starts at power plants where electricity is generated, and then it gets carried through high voltage transmission lines over long distances, and then finally drops down to smaller local power lines called distribution lines that bring electricity directly into homes and buildings. So ITC is the nation's largest independent electricity transmission company. And unlike other local power companies, we're uniquely focused on that transmission portion of that three-part system. So we develop, build, and maintain transmission infrastructure that holds that three-part system together, moving power from where it's generated to where it's needed, much like highways do within the country's network of roads.
Okay, well, thanks, Tim. Can you summarize for our viewers the work you do for ITC and why it's important?
Sure. At ITC, our goal is to keep that power flowing no matter what the conditions are outside. So I lead a team that works to make sure that we're prepared to support operations through any extreme weather or service interruptions that we may experience throughout the year. We complete a lot of studies, both months in advance and in real time, to determine whether we'll have adequate capacity during a peak load time, whether new manufacturing operations are onboarded, or even just during routine maintenance work on the system. We also use energy forecasts from the Mid-Continent Independent System Operator, or MISO as we call it, the electric grid operator for the central United States. So this organization kind of ensures that power flows are balanced across a large service area that includes 15 states and one Canadian province. So for example, if we expect peak electricity use, MISO works to balance that generation across our service area, and we make sure we have capacity on our lines to deliver that power. So as we shift from fossil fuel energy sources to renewable sources, we're taking a new approach to this work. In any given location, the sun doesn't always shine and the wind doesn't always blow. So we increasingly have to study and monitor each line's load in real time to respond to various situations we may see. We expect machine learning and artificial intelligence will probably play a role as this technology evolves.
That sounds like a lot of manual work. Is there any element that's automated?
Oh, sure. The grid does a self-check on itself every 5 minutes for N-1 contingencies. So this basically means that every 5 minutes, we know automatically whether the system will stay in operation if any one element of the grid goes offline. Regardless, it's essential that our team continues to analyze the current situation based on those results and any other alarm data that we may track, which does remain a manual process. So there may be times where more than one part of our grid goes offline, and we have to be prepared for those times as well. Additionally, if we plan maintenance for a day where some part of the grid does go offline, we have to remain nimble enough to reschedule it. So while automated updates are central to our strategy, ultimately our team of experts make all the decisions to ensure optimal operations.
So it really sounds like a multi-pronged approach. Can you describe specific examples of the kinds of things you're preparing for through this ongoing analysis?
So we have studies that look weeks or even months into the future, studies that cover what if situations and plans for as soon as tomorrow or even the current day. So in the summertime, we usually hit that peak demand as area residents run their air conditioners during the hottest parts of the day. So we want to make sure that everyone's power keeps running despite that spike. Additionally, as data centers and new manufacturing operations are built, we need to make sure we have the capacity to feed them power as well. And some of them require significant amounts of electricity around the clock. So we need to make sure that we're meeting this need to help grow our state's economic development. We're supporting this by completing project assessments surrounding our own upgrades to the grid. We often have to turn off the power on a line while we complete work. And we always try to make sure we can tolerate that temporary shutdown through our system redundancies. If we need to shut down a line, we try and plan to do it in a way that power can be rerouted so the end user doesn't even notice.
Okay. Well, I'm assuming the weather plays a big role in decision making then, right?
Oh, absolutely. We're monitoring the weather constantly, and I do mean constantly. Our team is always monitoring for potential weather challenges around the clock. Obviously, we can't plan for weather weeks in advance, but we can make sure we're prepared for any conditions that may arise. So, being able to change plans based on the conditions outside is where that nimbleness and flexibility are most important to us. So, sometimes if we see a storm coming or we have extreme heat or cold in the forecast, we can reschedule that maintenance work. This ultimately protects our crews and ensures that we have redundancies in case the storm damages a part of that line.
So, after your team conducts a study, how does ITC analyze the impact?
Well, if something does come up in that study that's unexpected, we'll utilize existing protocols typically to work or even work to develop a new operating plan to deal with any potential system conflicts. In a way, we always have a plan, and therefore we always can react and correct proactively in real time, minimizing the need to analyze after the fact. We do work continuously to improve processes for situations that we expect to happen again, such as storms. Learning and adjusting ensures that we have the most effective plans in place as our grid, the landscape, and our climate changes. Of course, no amount of line maintenance can help us predict equipment damage during extreme weather. So after storms, we'll routinely patrol lines on the ground or by helicopter even to check for damages or weak spot and make those repairs.
Okay, it's clear transmission is essential to our power grid, and ITC often talks about the need for increased transmission capacity. Can you comment on this?
Sure. As states and local utilities are moving toward their decarbonization goals, transmission has to be part of that conversation, especially since it will be more critical to have infrastructure with increasing reliance on renewables. Additionally, we're seeing an increase in electricity demand as people plug in everything from appliances to electric cars. Artificial intelligence and data centers are also expected to use more electricity in the coming years. So, as you can see, our lives are dependent 24/7 on electricity. This increased demand requires increased investments in the grid to ensure that can reliably meet our new and changing demands. The most effective approach, obviously, is being proactive and not reactive, especially knowing that it takes at least 7 to 10 years to build a new transmission line. So my team's work is essential to the reliability of the electrical grid. ITC always strives to maintain top quartile performance for all of our operating companies, which translates to fewer customer outages and exceptional reliability.
So, is there anything else you'd like to add before we wrap this up?
Sure. At ITC, we do pride ourselves on building and maintaining a system with enough redundancies to help prevent outages. So even when there are blips, our system can typically reroute power instantaneously so customers don't have to feel them. So much happens behind the scenes to ensure that we're being proactive and not reactive on a daily basis. So if you'd like to learn more about ITC, you can go to itcmichigan.com.